in the polar form. That is under the complex numbers which you must consider. Now, that will be concluding your question 3, which is sometimes maybe more than that 17 marks, but it's around the 17 marks. That's what you can get out of the question 3 of that. And from your question 3, we're moving on to your question 4. Question 4, your question 4 will then now be functions. This is where now marks are, where a lot of marks are, which is the functions. As a learner now, you must know your functions. You must know that under functions, what am I having? Under functions, we are having the quadratic or the parabola. We also have to know that under functions, we are having the linear function. We have the hyperbolic one, hyperbola. Let us also know that under this, from the hyperbola, we are also having the exponential function. And let us know each graph of us, how we deal with each graph of us. Let us not forget even the semicircle is part of this. Semicircle is also part of it. Let us know if we are talking to the quadratic function, what are the elements? How do we deal with the quadratic function? If it's a quadratic function or a parabola, where can we get marks? Each and every parabola, we know that it has got a turning point. One turning point. It has got only one turning point. And how do we get this, the coordinates of this turning point? Let us also know that we can just use x equal to minus b over 2a to find our parabola. And once we have found our x value, we take the x value, substitute in the given equation, and then from the given equation, we shall be able to get the corresponding y value. That will be our turning point on the parabola. After getting your turning point, you now have to know how to get your intercepts. Very key. Intercepts. On our intercept, you are having the x-intercepts, as well as the y-intercepts. The x-intercepts, that is where we say our y is equal to 0. And the y-intercept, of course, that is where we say our x is equal to 0. Indeed, we know that sometimes the graph can be written. The graph of that parabola can be drawn. And once the graph is drawn, then we must know, when we look at your graph and say, oh, this point and that point, because it is on the x-axis, it's A there, it's B there. These 2 points are on the x-axis. Automatically, that is where y is 0. And you have that point there, maybe it's point C at that point, automatically, because it is on the y-axis, that point, that is where x is equal to 0. So sometimes they will ask it to say, find the coordinates of these points, A, B, and C. Then you must know from a given equation, you just have, if to find those of A and B, you just let your y to be 0. And to find those of C, you just let your x to be 0. And then you'll be able to get the coordinates of that point. Then, talking to your turning point, you can use the equation x equal to minus b over 2a. If you have that equation. But if you don't have it and you have found the coordinates of A and B, this x value here, it will serve as the x of symmetry. It's right in the middle of the A and B there. So you can find it by just finding the midpoint of A and B there, then to get your x value. Then we'll be able to find its corresponding y value. That is with the with the parabola. And if you are to look at your hyperbola, looking at your hyperbola will always take the shape y is equal to, let's say, k over x plus q. This kind of hyperbola is telling us that because it's only x that appears there, that means the y-axis will serve as the vertical asymptote. The y-axis, the vertical asymptote, that is where x is equal to 0. Where x is equal to 0. It's serving as your vertical asymptote. And you also have got the q, which is now where you say, when I hide that, I'm now left with y equal to q. That y equal to q, it's now serving as my horizontal asymptote. My horizontal asymptote. So if now I'm expected to draw the graph, let's assume given y is equal to 3 over x plus 2. And I'm expected to draw this graph. Looking at this graph, automatically, I don't bother myself, but I start with the asymptote. The vertical one, automatically the vertical one will be the y. I know that. I will draw something like this, and then this is my y, this is my x. Then I know this is serving as my asymptote. As is the y-axis is also my asymptote. Then I also have got this one. Y equal to 2 is my horizontal. I go to where y is equal to 2. This is where y is equal to 2. It means I will have this line, which is passing through the 2 there. That's the line y is equal to, the line y equal to 2. It is now serving as my horizontal asymptote. Now, in terms, once I've done this, already I've got a mark. For giving that asymptote, I will get a mark. Out of that, then I must now get the arms, because once I'm talking to the hyperbola, it must have 2 arms. And by looking at the 3 is positive. Therefore, the arms are, the one arm is on the first, on the first quadrant. The one arm is on the first quadrant, whilst the other one will be on the fourth quadrant. It will just depend on that value. It depends on the value, because the hyperbola will definitely look like this. The other hyperbola will take the shape. If you're having your 2 there, it will take the shape like this. Now we need to know, if it's positive, the one arm is in the first quadrant of the asymptote, the quadrants that are formed by asymptote, not the quadrants of the Cartesian plane, but those that are formed by the asymptote. If it's positive, like the 3 is positive now, one arm is in the first quadrant, the other arm will be in the third quadrant. But if it was negative, then if the 3 there was negative, the one arm will appear this side, the other one will appear on the other side. It just depends on that. So we need to be careful when we are drawing our hyperbola in which quadrants, but not the quadrants of the axis, but the quadrants that are formed by the asymptotes of the graph. But the first thing we draw, let it be your asymptote. Then it will be followed by the arm that you are going to use there. And from the hyperbola, we are having the exponential graph. Exponential graph in the same way. The exponential graph. On your exponential graph, we need to know that your exponential graph, it may appear being an exponential graph of this nature. it may be an exponential graph of this nature. If you look at this exponential graph, we say this one is an increasing function, whilst we look at this one as a decreasing function. It's an increasing function because as the values of x increases, the y values of the graph also increases. But you look at that graph, you realize the graph is getting closer to the y-axis there, but it won't touch the y-axis. And that's what it's simply telling that the x-axis, simply telling that the x-axis here is serving as the asymptote of that graph, which can take the equation y is equal to 2 to power x. The asymptote there, it is the x-axis, and it's an increasing function because that base it's a whole number, not a fraction. But this type, we may find this one being y is equal to maybe 1 over 2 to power x. That one has got the base of a fraction. That's why our graph is decreasing, but with just one asymptote as compared to the previous one of the hyperbola, which was having 2 asymptotes. This one has got only 1 asymptote. That is the exponential graph, which of course also when you have to draw it, the intercept very key. The intercept very key. Find your y-intercept. It will indicate that is your y-intercept there, where the graph is cutting the y-axis, and your graph, whether it's increasing or decreasing, is very key. The shape of it, it's giving learners marks also. And beyond the exponential, then we are having the one of the semicircle. The semicircle. On our semicircle, of course, we understand that it's half of a circle, but we're only taking either the top part or the part that appears below. The equation of that will be in the form y is equal to, let's assume y is equal to a positive square root of 3 minus x squared. This is the one that has got, let's say, concave down, or it may have y equal to minus the square root of 3 minus x squared. So the difference is that this one is positive, while this one is negative, but we are talking to that. Let us know that from a given, it must be a half of a circle, like that, and when you work it out, you'll be able to can get also intercepts. Very important to get the intercepts when you are drawing that. To get this coordinate of A, coordinate of B, coordinate of C, and you realize the space from here to there is equal to the space from there to there, is equal to the space from there to there. So we need to be able to can get that. And at some point, the examiner can be just clever, and on this same graph of the semicircle, the examiner can somehow draw a straight line. And after drawing the straight line, the examiner can put a point there. And say this point has got coordinates 3 and 3. And the examiner will now say what is the equation of the line if the straight line, that means now he's bringing in the linear in the form of a tangent. He's bringing in the linear in the form of a tangent into the semicircle. So let us not separate the idea that we have from the Euclidean geometry with what is happening in paper 1. That if it's given like that, we know to find a tangent, of course, the straight line. To find the equation of a straight line, we may need just a point. We need a point. We also need a gradient. A point and a gradient, and automatically right now a point is there, 3 and 3. 3 and 3. Now we need to find the gradient so that we can talk the equation of this line which is attached to our semicircle. So to find that, let us not forget that it's a semicircle. The center there is at the origin, 0 and 0. And that can give us now a radius there. And that radius, because it's touching that radius is touching our straight line, which is a tangent at that point. The understanding is that it will be giving an angle of 90 degrees. And they are perpendicular. And by virtue of saying they're perpendicular, what we know is that the gradient of the tangent multiplied by the gradient of the radius, they will always give us a -1. But we are able to get, this is our radius. Find the gradient of the radius, of course, there it is, it's easy to get. It's going to be 3 over 3, which is equal to 1. Therefore, the gradient of the tangent will then be -1. Now you are having the gradient, we're having a point. It's easy for us to can get now the equation of that, which we can just use y minus y1 equal to m into x minus x1, or somebody can just use y equal to mx plus c and do the substitution on that one. Y minus y1, our y1 is mostly 3, is equal to the gradient, it's a -1. X minus our x1 is another 3. That is y minus 3 is minus x plus 3. Y is equal to minus x. 3 plus 3 there is giving us a 6. So the equation of the tangent will be y equal to minus x plus 6. That is if the examiner has just decided to include a straight line on our semicircle. So it shows that from the question we shall have had all the functions that we can talk of. We started with the quadratic, we talked to the hyperbola, we talked to the exponential, we talked to semicircle, and ultimately he's bringing, on the semicircle, he's bringing the linear function there, which of course will conclude in terms of that question 4, like I said, it carries a lot of marks. That is where we must make sure that we don't just lose those marks, but we pocket those marks there. And moving on to your question 5, our question 5, it will be finance. On finance, let's just a matter of working with formulae. A lot of formulae that must be used, because on finance we expect the question that will be talking to the effective versus the nominal rate. Effective versus the nominal rate, which the formula is on our formula sheet, the formula sheet which is on our question paper, which we must always visit. We must also not forget that there will be a question from the effective. Let's remember the question around the compound interest, reducing balance. Let us not forget that. Reducing balance, as well as the compound. We must now be able to read the scenario well and understand what formula should be applied. Is it reducing? Is it just a compound interest type of question? And let us also, the question that may come in, it may be a question that is definitely talking to the different times. That is where now your timeline can assist you. Different rates being used on the same question. For the first 2 years, this is happening. For the next 2 years, this is happening. A person may invest for the first two years. After investing, after 2 years, then the person decides to withdraw money, and then you change now. You have invested, it means you were on compound, and then you withdraw. Then from there, you are taking something, you subtract from that, and then from there, you carry on investing. After withdrawal, now you have a new principal which is still being kept in there as a compound, but there should be a timeline talking to that to say what happened after a certain period of time. So we must be able to know which formula do we bring in and deal with our finance on that one. That is basically the type of question which may worth 15 marks at most for that financial mathematics there. And then from there, moving on to the next one, which is our question 6. Question 6. Well, our question 6 is calculus. Calculus. A lot of marks because this topic, calculus, is a topic that we only get in grade 12. All these other ones which I talked of, they are in grade 11, they are there in grade 10. Grade 11, grade 10, it means they can even assist the young ones. But once we talk in calculus, then this is the topic that was taught in grade 12. And first thing that we need to know, and when we come across the issue of the question of calculus, let us know how to differentiate using the first principles. Differentiate using the first principles. And we know that that question will come either as y equal to x, they can put it like that, or not using y but using f at x equal to x. They may come and say f at x equal to x plus 3. It's always linear. They may come, use it as f at x equal to, if they want to trick you, 3 minus 2x. They may come and use a different one as f at x equal to, at some point, they can put 7. Let us expect this kind of questions and be able to know what is that. And once they're talking, differentiate using the first principle, the expectation is that use from your formula sheet, you get the formula, first principle, f at the derivative of x, which is equal to the limit as h approaches 0 of f at x plus h minus f at x all over h. This is the formula that we use when we are faced with the first principle, which is from our formula sheet. But what is key for our learners is be able to find out the f at x plus h from the given function, because that's where now it confuses us. So we normally say use them, work it out separately. If let's assume that our question is f at x is equal to, let me take this one, 7 minus 3x as our f at x. Before you go anywhere, you know that your derivative formula is going to need f at x plus h. This is your f at x. Find out what is your f at x plus h from this one. It means where you have your x, put now the x plus h, which means now you are having 7 minus 3 into x plus h. Work it out as 7 minus 3x minus 3h. There it is. That is your f at x plus h. Then from there, bring that formula, as you will be taking it from your formula sheet, as the derivative of x is equal to the limit as h approaches 0 of f at x plus h minus f at x all over h. Please write it down, because you will get a mark for writing that formula, even though it is from the formula sheet. Then after writing it down, move it, limit as h approaches 0. Now what is the f at x plus h? Write what you got over there. 7 minus 3x minus 3h. Subtract. What are you subtracting? F at x. What is our f at x? Our f at x, as it's given, 7 minus 3x. That's all over h. It's very wise to put brackets there, or else, if you don't put brackets, make sure that you have multiplied by that negative already. The limit as h approaches 0 of 7 minus 3x minus 3h minus 7 plus 3x all over h. Work it out, then you get your limit as h approaches 0. Now you add those 7 minus 7 is a 0 there, minus 3x plus 3x is a 0. You are only left with minus 3h over h. And the h will cancel the h, will be left with the limit as h approaches 0 of just minus 3, and our final answer will just be a minus 3. Make sure that you go down with writing the limit, don't get tired, and check where the equal sign is. The equal sign is between the notation, the derivative, as well as the limit as h approaches 0. Go down with the equal sign up until you simplify and get that as your final answer. That is when you are using the first principle. You are differentiating using the first principle in every question. That will be your first question on calculus. The second question on calculus, I mean not question, but the sub-question on calculus. The second question, it will now be how to differentiate using the rules. Differentiate now using the rules. A lot of questions may come there, but out of all those questions, let us know that there are 3 things that we must guard against before we can differentiate using the rules. And which are those things? We must make sure that on the given function, on a given expression of us, let us make sure that there are no brackets. Make sure that there are no brackets. If there are brackets, multiply them out. Multiply them out before you can differentiate. Secondly, make sure that if there is a fraction, make sure that x, if you are to differentiate with respect to x, make sure that x is not appearing on the denominator of the fraction. X should not appear on the denominator of the fraction. If x is on the denominator, make sure that you simplify that first. In other words, I'm saying if you are given f at x equal to 1 over 2x, for an example, before you can use the rules in differentiating this, make sure you see this as your half multiplied by 1 over x, whereby the 1 over x can be expressed as x to power negative 1. Once it's like this, x is no more appearing on the denominator. It's written exponentially with a negative number, negative exponent there. Then we can differentiate once we have done. We are just simplifying. We are not differentiating there. And the third element is to make sure that there are no sets. No sets involved. No sets involved. Because we can't differentiate if there are sets. What do I mean by no sets involved? Our function can be, just for an example, the square root of x to power 3 minus 1 over x squared. And I've involved 2 things there. First one, this is the set I'm talking about. We cannot work it like that. And because the square root, let's make sure we write this as x to power this 3 over 2 because it's the square root minus this one. We'll be talking to that one. Instead of having it as 1 over x squared, it will be x to power negative 2. In so doing, you are just simplifying. It's not that you are differentiating. You were just simplifying, and you also just you may get just a mark, either 1 mark for that or just a mark for each there. But this is no more a set. Then you can differentiate once you have simplified it like that. These are the 3 things that you must guard against: brackets, the fraction, as well as no sets. If you can guard against those, then you'll be able to use the rules in differentiating there on that part of calculus where we are using the rules. And once you have worked on your rules, you may come to the next question out of this, still on calculus. You may come against the other questions. Sometimes they separate this from the whole question. They can ask it somewhere, but let us know how to find the equation of the tangent. the equation of the tangent to the given curve at a given x value. Let us be careful of that. They can tell you f at x is equal to x to power, let's say 3 minus 2x plus 1. This is the function. And at x equal to minus 2. They say to you, find the equation of the tangent to this curve. F at x equal to x cubed minus 2x plus 1. At x equal to minus 2. Then please let us not force ourselves to draw the graph and show the tangent. No. But let us know that under calculus, once we are talking to the derivative that we talked of on the first principle, once we talk derivative, what is this derivative giving us? It's giving us what we call the gradient function. The derivative is giving us the gradient function. In other words, from the derivative, we can get the gradient. So if it's given like this and we want the equation of the tangent, firstly, we know tangent is a straight line, we need a point. For a point, x value is there, is equal to minus 2. Put the x value in the place of that and find f at 2. Our f at 2 will then be 2 to the power 3 minus 2 into 2 plus 1, giving us the 8 minus 4 plus 1, which is equal to 4 plus 1, which is a 5. That is telling us that if x is minus 2, y is equal to 5. We have a point. Now we are in need of a gradient. To find the gradient, let's find the derivative of our function. We find the derivative of our function, which will then be 3x squared minus 2. Out of this, then we find the derivative at that given x value. The derivative at minus 2. Which will then give us minus 2 squared is 4 times 3 is 12 minus that is 10. This 10 that we are getting is actually the gradient of the tangent at that x equal to minus 2. So at the moment, we are having a point, we are having find the equation of the tangent, which of course we shall just use y minus y1 is equal to m into x minus x1. You can just substitute that. It's y minus 5 is 10 into x plus 2, which is giving us y minus 5, which is 10x plus 20, y equal to 10x, 20 plus that is plus 25. This will then be the equation of the tangent. Let us expect such a question, because the tangent is, to find the equation, the idea of the derivative is used as it is from the calculus part of it. That is what we can get on our question 6, where it ends. Then we can find question 7 of our paper. And the question 7 of our paper, let us understand it will be the cubic function. This will be the cubic function. Cubic function. Let us understand that with the cubic function, yes, we can be able to draw the cubic function. Y is equal to, I'm just writing it as an example, x to the power 3 minus 2x squared plus 3x minus 4, something like that. So that's the one equation that we may have of a cubic function. And maybe they can ask you to draw this type of a cubic function, and then you will draw it, of course. It will be drawn, and then it can give the shape like that. And then you have the coordinates like that. This is a turning point up there. There's another turning point over there. But let us pay more attention on if it is drawn and you are given the coordinates A, B, C, D and E. Yeah, let us focus more on if it is drawn. And if it's drawn, how do we find the solutions to it as it is drawn? Let us always know the graph can take this shape. If it's taking the shape of this, then we know where A is, where C is, where E is. Those are the x-intercepts. And once we're talking the x-intercepts, how do you find them? That is where y is equal to 0. Put y equal to 0 and solve. Then you'll be getting the coordinates of A, B, A, C, and E. That is the one question that they can ask. Draw it, they have drawn the sketch for yourself. You must find the coordinates. And you must just know where A, where C, where E is. The position is very key. Where are those? Or the other point will be here. Let me call it point F of mine. It will be there. And if you look at that point F, this point F now, it is on the y-axis. And on the y-axis, on the y-axis, now that's where our point F is. That's where the graph is cutting the y-axis. That is the y-intercept. And for the y-intercept, x is equal to 0. For the y-intercept, x is equal to 0. That's for point F. If once you see that point, and you know that at F, that's where the x is equal to 0, then you won't go wrong. You'll be able to put 0 in the place of x because the equation will be given. You just substitute in the place of that equation. Put the zeros, and then you'll be able to get the coordinates of that point F. It's free marks if it's like that. Then you are having point B and point D. Point B and point D. These 2 points now are at the turning points. At the turning points, that is where you're taking your derivative. And that's where your derivative is 0. That's for point B and point D. You know that at those 2 points, these are the turning points, the stationary points. The gradient of the tangent there is 0. So the derivative is 0. So you'll be able to can equate the derivative to 0, and then from there you solve for x, and then you'll come up with the coordinates. It's very key. So let us please practice more on the drawn sketches, how to find the coordinates rather than drawing the sketch this time. Please let us practice more on the drawn sketch and follow the information that I just shared there with the cubic function. That is basically the cubic function on question 7 and on our question 8. On our question 8, or x for which the area will be minimum, then you must know if you were working on area, then you say differentiate the area and equate it to 0 and solve for the variable. If it's x, solve for x. Then the x value you get there, it will be the x value for the maximum or the minimum. At some point they ask it in terms of motion. Motion, that is where they will put the displacement equation, and on if it's a motion and it asks like using displacement, just look for the word. Once they say they use the word the rate, then know that from that, because with displacement will be as a t. From that, once they say what will be the time for which the rate, once they bring the rate, talk of the derivative of that. derive it, and the t that you will get, it will be giving you from displacement you go to the velocity. From the velocity you can go to the acceleration. That is the question 8 of that calculus. If you look at that calculus, it takes a big volume. It takes a big volume, which is 3 questions that can give you something like 30 to 35 marks. Just working with the idea of the calculus on that one. And then the last one will be on question 9. Your question 9 there, we talked calculus where we were differentiating. Question 9 is talking to the integration. When we're talking to the integration, we are having one whereby question may just say integrate. You'll be expected to integrate, and that one will be talking to the indefinite integral. And once it is the indefinite integral, we know sometimes it becomes very easy that to collect a mark, if it's, let's say they wanted the integral of 3x, so let's put it 3x and dx. Let us know that the expectation is that with integration is the same as reversing. Is the same as reversing the differentiation. Because with differentiation, we were subtracting the exponents. Therefore, with this one, we must now add. In other words, if we are to get to the answer to this one, expectation, we say we take this 3x to power, of course, is 1. We add a 1 over 1 plus 1. But the key thing there, we just have to put plus c. And once we said plus c, there is a mark for that. And this answer will then be 3x squared all over 2 plus c. That is for our indefinite integral. That's how we get it. It's easy just to work within that rule. But if it's indefinite, let's make sure that there is a c when we are determining that indefinite integral. But beyond the indefinite integral, we may come across the definite integrals. The definite integrals, with our definite integrals, remember, we are actually looking for the area. The area, we are looking for the area between the curve and the x-axis. The area between the curve and the x-axis. And how do we find that area? We find the area using the definite integral, which of course, if it's given like, let's say you are given, they've drawn the sketch, they've drawn a parabola like that, x equal to 2 there, x equal to 4 there, and this part is so much shade, they shade that. In other words, you are expected to find the area below that curve. You will be given the equation of the curve. They can give it as gx equal to x squared minus, let me say, minus x, something like that. It's just given. I'm not saying that's the equation. It may be something like that. But what is the expectation? They only look for the equation, for the area that is falling between the curve and the x-axis, but within this. In essence, how do we see it? We must see it as the integral with the upper limit 4, the lower limit 2 of this x squared minus x dx. In essence, this is what it's talking about. And to do that, we would then have to integrate this. You move down with it and say, okay, let's integrate this. When we integrate it, it's going to give us x to power 2 plus 1 over 2 plus 1 minus x to power 1 plus 1 over 1 plus 1. Close your bracket there. Close the bracket there. And then have the upper limit, the lower limit. And that is going to give you x to power 3 over 3 minus x squared over 2. You have something like this. The upper limit, the lower limit. And from there, the expectation will then be, you will now have to substitute the upper limit, have it as 4 to power 3 over 3 minus 4 squared over 2 over 4 to power 3 minus 4 to power 2 over 2. This subtract when you substitute this one, which is 2 to power 3 over 3 minus 2 to power 2 over 2, like that. And then you just have to simplify and get the answer. The answer we get when we simplify these two brackets, it will be the area to that one. But at some point, you may find having a sketch like this one. And this part is shaded. This part is also shaded. And expected. Then we are given the equation of this, a cubic function, of course. You are given that gx being equal to x to power 3 minus 11x squared plus 24x, given something like that, and then they will always give you the coordinates here. They will always give the coordinates there. They say it's 1, they say 3 there, they put maybe 8 there. What is going to happen? You must now find the area of the first portion. The area of this first portion, it will be positive. That is between x equal to 1 and x equal to 3. Then you find the second area. You'll get the area of the second portion. The area of the second portion, which will now be negative. Don't be amazed. The area of the second one, that is between x equal to 3 and between x equal to 3 and x equal to 8. This area will be negative. The negative part of that area is just showing us that the curve or the area we are talking about is below the x-axis. It's below the x-axis. And if we are to find the total area of the two, you say, in other words, you are looking for the area of the first plus area of the second. You will take the first area being positive, add it to the second area but being positive. That negative was only telling us that this area is below. We cannot come and add it being negative. It was just telling that the area is below the x-axis. But if we want the final area, which is bounded by the curve, the marked area there, we add the two areas being positive, and that will then be giving us the solution. But the way we get to that, the same way that we did with the previous one, you take the first, find from 1 to 3, you find the integral of the first one, the integral upper limit is 3, the lower limit is 1 of the given function x to power 3 minus 11x squared plus 24x dx. You find this one, then you go to the next, you find the integral from Upper limit is 8, the lower limit is now 3 of x cubed minus 11x squared plus 24x dx. This is going to give us area of the first. This will give us area of the second. This is where I'm saying this will be a negative area and that will be a positive area, but we add the two, and considering this one being positive, where you add them. And then that will then be giving us a final area which is bounded by the curve between the curve and the x-axis. And that will then give us the picture of the question paper that we'll be expecting come Friday. And we are saying good luck to all our matriculants, because we believe that if we can do our practice having all this in our minds, firstly, you must make sure that we read the question thoroughly. Let us make sure that we understand what is there that is needed by a question, but have the picture that question 1, it will be solved for x, 2, it will be your nature of the roots, 3, it will be your exponents, logarithms, sets, 4, it will be your functions, 5, it will be your finance, 6, it will be the calculus part of it, which of course we are saying carries a lot, and part of calculus on question 7, which will be cubic function, and part of calculus, which will be the application on question 8, and then integration will be on question 9. And that is where our marks will be. And lastly, after I've talked to all the needed things on my question, on question paper, it's just to throw a quiz to all the matriculants that are listening, which of course they've been my good audience, I believe. I believe that we have heard that that I was trying to drive home, and you must just go deep into practicing all your questions, practice and make sure that you don't stress yourself. You must relax after you have done all the questions, the types of questions. Relax on your Thursday. Don't do this thing of cross-nighting, but give yourself time just to relax. And on Friday, you somehow nail the paper that will come in front of you. But the quiz that I'm putting in front of you is, when I was talking here, I mentioned that on my question 2, where I'm having the nature of the roots, and I mentioned that nature of the roots, the question will come saying, determine the nature of the roots without solving the equation. But I said there is an expression that must be used. I want you to give me that expression that must be used in finding or describing the nature of the roots without solving. Give the expression that is to be used to determine the nature of the roots without solving. And for those that are not listening on the radio, on those that are on Facebook, on Twitter, on YouTube, your answers can be posted on that, and they can be posted to the Department of Education. And good luck to everyone for your examination, for your technical mathematics examination, which I know that with my educators that we are driving this, we always spot on and fighting for perfection, and we always give our learners what they need, what they deserve. Good luck to everyone. Thank you very much.